Today solve the question of interview bit, which is find the shortest unique prefix for every word in given list. Basically, this is the questions of try and loop for loop. So we can solve this question using a try. So let's understand the what is the problem statement is right now. So we are given an array which have a multiple words like zebra, dog, duck, and love. So what the question is expecting? So question expecting is that we have to print the prefix which is not repeated. For example, Z. As we can see here, Z word is not it's a unique character in the given array words. For example, Z is common, not common for dog, duck, and duck. So next, so we can print the zebra for Z, and next is a dog. So as we can see here, D is repeated on the word duck, dog. So we can't print the D only. So let's jump to the dog, dog O. So we can see here in the index of second, in the word of dog, in the word of dog in the index of second, we can see here O is repeated, and next is a dog. As we can see here, the third character is G. G is not repeating at the index of 3, so we can print the dog for the dog word. Next is a duck. As we can see here, D is repeated in the dog and dog word, so we cannot print the D only. Now let's jump to the U, and U is not repeating the character at the index 2, so we can print the du for the duck word. And next is a duck. So as we can see here, d is repeated for dog, duck at the index 1, and next character is o. So o is the frequency at the index of second index. So as we can see in dog, g is o is repeating for dog, so now we can't print the do. So let's jump to the third character, which is v. So as we can see here, v is not repeating at the index of third, so we can print the dog. So this is the problem statement of find the shortest unique prefix for every word. So let's understand the with the specific word and the answer. So for example, zebra for z, dog for dog, and duck for d, dove for dog. So this is the so we can solve this question using the for loop, using a two for loop. So but on today we are going to solve this question using a try data structure. So as we already know what is tree data structure, so now I'm going to implement this on the try, sorry. So let's create a root try. So in the root try, we initialize, add the word in this try. Let's say example z, zebra. So as we can see here in root, there is no z word linked with the root, so we are creating a new z character with the associated with root. So now I'm creating a z. So as we can see here, second word is e, so we can add a e character with a frequency of 1, because we going to print our answer with the according of frequency 1. So next is b. So b, z, e, b. Now next is r. So we can add after b, after just after e, and next is r. So we can add r just after the b, and third one is a. So we can implement the zebra word in a root try. And the next word is dog. So dog, now we can see here there is no d word is associated with root. Now I'm creating a new character which is linked to the root at the first first character d. So now d. So we next frequency is 1. First frequency is 1. So next is o. So d. But then we create a o with the d, and after that d is also starting at the initial phase when the frequency is 1. And now add a dog, g, for the dog. So we can add a d, o, and then after o we can add a g, which frequency is also frequency 1. Now jump to the duck, duck word. So as we can see here, d is already present at the root center. So now I'm going to now I'm not going to create a new character with associate with root. Now I'm using a d as well as, and now increment the frequency as 2, because d is already used in dog word. Next is u. So no, I'm sorry, I have to add this u with this. So I will fix it. So next is du. Next a c character. Now I'm going to create add a leaves with a U just after the U leaves, and the frequency is still 1 because there is no linking between the C. And next is K. So as implementing C, we can add a K just after the C. Next word is dove. So we are going to create a dove. So firstly, D, as D already present, so we increment the frequency by 1, which is now frequency is 3. Next is O. So we already O is present in the tree structure, so we are going to just increment the frequency of O. Now add a V. So as we can know, with the O, there is no word, no character link. Character is V. So now I'm going to create a new character link with O. So we are add a character V with the O. So after that, next is E. So we can add a E leaf with the just after the V, and the frequency of E character is 1. So this is the initialization of a tree. So what is your answer? So as we can see here for zebra Z. So as we can jump when we jump to the Z, so we can see the frequency of Z is 1. So no need to jump to the next word, just print the Z. And next is dog. So as we can see here, first the dog first character of dog is G, which is frequency is 3, so which is repeating, so we can't print the D. So next is O. So we can see here O is also frequency of 2, so we can't print the O. So next jump to the Z. So as we can see here, G is the frequency having 1, so we print the dog for the dog. And next is a duck. So next is duck. As we can see here, though sorry for that, I have to link this U with U. So just give me a second, I will add it. Where is the features? Frequency, pictures, table, smart shapes, and pay restrictions. Oh, so no, sorry, I'm not searching how can add a line with it. Basically, I'm creating these tree in PPT. That's why. So just imagine this U is connected with U D. So okay. So next word is D. So as we know, the D's frequency is frequency 3. We can't print the D. So next word is O. So we know O is already present, which having the frequency is 2. So we can't print D O. Next is V. So when we jump to the V, oh sorry, okay V. So as we know, frequency is 2 and the V is frequency 1. So we print the duck, so DOV for this. And next is a duck, which I already explained. So let's jump to the problem statement where we can code this problem statement. Give me just a second, I find out the exact interpret. Shortest unique prefix. So in an interview with, we can call the same question as the shortest unique prefix. So let's firstly we have to create a structure for the try T. Give me just a second. So firstly we have to create a structure. Name is node, where we can initialize the every node of the trend. In the node we already discussed, in every node first is a character and second is the frequency. So let's create a first frequency, frequency, which is, and next is int AR, array of 26. So as we know, there is 26 alphabet in English, so we are going to create an array. So like for example, we are creating a root. Okay, in root we have a multiple Z D. So when we found a Z, so we just store the Z at the place of array Z 26. So we can store the Z. So when we find a Z, so we can directly jump to the that array, and we also increase the frequency with a Z. So this is the use of array in it. So let's create a construction for the thing. So when we call this frequency, the construction is automatically invoked, because this is the functionality of constructor. So I is smaller than 26. So when we slice the word new node in a try, so uh, we can slice the all element in the array with a null. So if we found any leaf with any character with that character, we can just change the null with the exact value. Okay. I plus plus array of I is equal to null. And always after that, oh yes. And now I'm going to create a function which is add function. We can use that function to create a tree of giving words. So now I'm going to create a add function. So first is a node, because we pass a root node. Always pass a root node in that add function, because we create one root for whole program. So we can mm, initialize the function with a node parameter along with the string, which we passed directly from the main function, which is to which initialize the all character in a tree. And next is the index. Index. We will explain the why we used index here. So first is if. So as we can create a void function, so in the function we need a one break statement. So we are going to use this function as a recursion. So if idx is equal to size dot size. So for example, if there is no uh, character in a word, so we can directly uh, return from that part. So let's first, if we check, first we have to check there's a character which is we are going to in slice with the root as already present or not. So let's root ar s idx index minus a. F is equal to null. It's mean the which character we are going to slice in the root they are not present. So we can add this character in a root. So creating a root, uh, add ar, create s index, s index minus a. We are going just minus a if we have a character. If we, let's see, for example, we have a character c. Character c, we can the sky value of c is whatever minus a. So we can slice that word in a array. Click on and equal to new node. And next is root. So if the element is not present, just we can add that character in root. So what else if we present, if we already present, so we can increment the frequency by 1. So as we can see here, ar of s index idx idx index minus a, which frequency FRE plus plus. So we can increment the frequency of repeating character at that moment. After that, we can just call same function again for the next character. Root AR S IDX index. I think we are getting index here. Index minus a, passes same string again with the newest index plus 1, just store the next character of the word. And this is the how we can slice the add function in a sorted unique prefix. So we can use this function to create a tree, and next function we are going to use to find a prefix. So first create a void function, sorry, print a int. So we can just pass the index of the repeat non-repeating character of the word. So int find node root string, pass a string int index the same as index. So if this condition, if root ar s idx minus a, if frequency is 1, so we can just return that index of the word. So we can index index. So as we can see here, already explained it on the graph. For example, for uh, zebra, we can see when we found a frequency is 1, just return the index of that word, so we can print the z. So let's see, for example, we can for dog. So for dog, d frequency is 3, we can't return. For o, frequency is 2, and we can't return. And third one is the frequency is 1. So when we found a frequency 1, just return the index of that word, so we can print the doc. So we can uh, create a break statement in this find function. Now I'm going to complete the thread function. For example, root of ar as index minus a not equal to null. If so we can check if the index given value is index given character having a null, so we can just return the just recall that function again. Because for example, if have a root, so we can call the d, so we can say here there is in array d array, the position of d is not null, so we can call that find function again for o. This is the use of if condition at that part. So click on now, call that function again. Basic, this is the recursion, so we are already know. If you don't know, so we can also create a video in future on the recursion. Root ar s idx a s index plus just increment the index, so we can jump to the next character. So if this is not present, for example, we are reached at the position, there is no string, no word, so we can just return -1. So now I'm jump to the main solution prefix function. So firstly we have to create a new node. Sorry, yes, firstly we have to create a new, then we have to create a n where we can store the number of a word in a string. Ar dot size, sorry for interruption, vector string. We are creating a string where we can store the answer, vector is string. So firstly we have to create a call a add function where we can slice our create our tree with given words. So I plus plus. So and pass that root. Sorry, I think we have missed the creator new root, try root. So create the node root is equal to new node node add. So we can call the add function. So create a tree. So firstly we have passed the root tree, which is that means lies in main function. Next is AR. So we can call this. We can just pass word again and again with the pass this and add function and pass the index starting index is 0. So we can create a tree using the for loop. So after that, now I'm going to check the shortest unique prefix. So for checking the shortest unique prefix, create a one function for loop. This lies with I 0 to I smaller than n number of words in a string I plus plus. So first create an index, uh, store the index where the frequency is 1. Yes, we can call our find function here to just store the index where the frequency of the character at the particular word is 1. So we pass the root as we are creating in this function along with the array. Array we can say string a word here and 0. So with the help of these find function we can uh, return our index where the frequency of the character is 1. So when we find the character index of the frequency of the word, so now I'm going to create a string s is equal to string s is 0. So for a u 2, so we retrieve a character by character and store in the as a string to print the value of string. Answer we can say auto it it fetch. This is the visualization of continuous auto function. I if index is smaller than 0, so we can break this loop. Next, so we can add a word in a string. So we can also index. So we can decrease our index here. index decrease. So if we have a 3 character, so we can print a 3 here. मतलब ये नहीं ठीक है क्या जी? ठीक है ठीक है. Index we don't push back, so we can store that string which we are created in these loop. So for example zebra answer is stored in s string, so now push our s string in the v uh, v v vector string. Okay, so push our string here. So let's run this task here. So dash line input string here, just click on test. So we, as expecting, we are getting error on line 11. I think expecting yes. There's a structure we put in semicolon. So in the void add function, we forget to slice index string index. See, and So at 17 error cannot be controlled. Convert node to int assignment is equal to new node. Pass. Create a null. So just copy that part here. Run this part again. I'm getting a seam error. Cannot convert a node root AR. Okay, new node. Node int an assignment. Oh, we are missing this here. Frequency node frequency 0 string getting error cannot convert node. The function void add. Let me check the first again. Creating a add node root string s index I index if index is equal to size of return we can directly return okay if root ar is index minus a is equal to null. So I think we are using a compiler. Can compiler? Yes. C++. That's working fine. If root ar index so add root ar s. What is s? S is a string here. So let me copy the same bit root. So just root array I condition root node root. So what's wrong? Array cannot convert node to int. So let's copy this code. Sure, sure. Travel successful. As we can see here, the code is successfully loaded. So this is the solution. Right? Your short estimate prefix. Stop.